There we go. All right, I'm gonna open the room up and let everyone in. All right, welcome everyone. Let everyone join. We have some viewers also on YouTube. If you're in the YouTube, you'll need to come into the Discord or into the Zoom chat if you want to do live questions, because the questions can be posted by everyone in the Zoom chat. Hi everyone, I'm Andrew with ETH Global. You have just joined the 4 p.m. Eastern workshop. I don't know what time zone you're in. Everyone's from all over the world. We are here with Michelle Lee of Protocol Labs. She's going to be doing a presentation, an introduction to IPFS and Filecoin. We can take questions in the Zoom chat. Feel free to do that. We can cover that at the end. And at this point, I'll just let Michelle take over. Thanks.
Thank you. It's great to be here. Let me get the screen sharing set up for this talk. All right, how's everyone doing today? Thanks for coming. Happy Monday. It's great to be here. I'm really excited to talk with you all about decentralized storage. I'm going to assume that if you're at an ETHOnline or ETH Global event, that maybe smart contracts is what draws the majority of you in. And I'll talk a little bit about application architectures, how smart contracts relate to decentralized storage, how IPFS and Filecoin work in brief, and then some of the possibilities and building blocks you can use to kind of get started with this ecosystem. I'll check the chat periodically, so feel free to drop some notes, questions, anything you want to know in there. So today I'll cover IPFS and Filecoin, talk through some of the core concepts and explore possibilities. In this session, we're not planning to do any deep dives into cryptography or economics or hands-on tutorials, but I have a lot of links for you all. So hopefully this can be a great launch pad for learning more if you're interested. Like I said, let's zoom back a little bit. I think this is, a really exciting time in the history of the web because we're at the cusp of this transition from everything being sort of Web 2 based to introducing Web 3 in a lot of different ways. So if you think of, this colorful set of rectangles is one way we can think about application architectures, right? So we've got front end in the red on top, and then that front end is driven by logic, whether it's smart contracts or standard application logic. Again, different ways to combine Web 2 and Web 3 logic. And then underneath that logic, you have your data. So you can have lots of decentralized data solutions. You can have Web 2 data solutions. And today I'm really excited to dig into different ways you can combine some of these tools. So, like I said, you can have fully decentralized apps top to bottom. You can have combinations of the two, lots of different possibilities today. And I think, we're seeing the majority of apps that use decentralized tech, whether it's Ethereum or side chains or, new smart contract platforms, all, making really creative use of the possibilities available. I want to also highlight this yellow block, which I'll dig into more a little bit later. It's what we call storage helpers. And these are tools that make it really easy and developer friendly to connect the Filecoin and IPFS network to your decentralized apps. So we're going to dig into some examples very, very soon. But first, what the heck is IPFS? So IPFS stands for Interplanetary File System. It's a little bit of a misnomer because it's not like a Dropbox or box where you can just upload your files and get them back in exactly the same way you put them online. The exciting parts about this are that it's fully distributed. There's no central server. It takes advantage of some content addressing schemes, essentially like fingerprints for your data that make it really resilient to disruption, that make it really efficient. And overall, it's a new approach to the web that breaks free of the centralized services that have grown larger and larger and taken over the 90% of our web traffic. There are two important concepts to understand from IPFS. The first is the peer or the node. You'll hear these terms used interchangeably. And a node in IPFS, does a whole bunch of different things, anything from providing services to other peers, having a unique ID, setting up encrypted communication channels. But it is essentially part of a network or a swarm, if you will. It's kind of the atomic unit of a peer-to-peer network. Every peer also has an identity and like this QMTU has a long address like that's used to identify it in the network. Okay, so we've got our network of peers. Once they connect to each other, what content do they have? How do they know what content each, any other peer holds? This is the other kind of key concept of IPFS that's really exciting. So in the traditional web, every file has a file name, and you end up with files like final copy, version 8. With content addressing, we run data through a one-way hash function that produces a unique and reproducible fingerprint called a CID, content ID. So instead of index.html, for example, you get a CID out of it. And in this diagram to the right, you can see it's actually a tree of cascading CIDs that all make up the routes to your data. So if your data comes in and gets a new file name, we actually can uniquely identify that, match that, and it provides a great and resilient way for nodes to fetch data from other peers and also have trust in what that content is. When you use this decentralized network in the wild, there are a couple operational things to consider. So who actually runs this global network of decentralized nodes and why, right? So you can run your own node, which is fun and a really cool exercise, and you can participate in this peer-to-peer network. But if you're running at production scale, you need other things to happen, right? You can't just kind of like shut down your computer and have your data go online. So you can hope your content becomes popular enough that other nodes want to pin it. You can also run your own network of nodes, which is what a lot of production users do. So they'll manage clusters of 10 nodes around the world, for example, or you'll have an academic research team in a few different locations globally, all run nodes so that they can, update their data across the entire network. But this does require some infrastructure work, and not everyone wants to take that on. Lastly, you can also pay a pinning service. It's basically a hosting service to store your content on their IPFS nodes. And there are a few great companies, Pinata, Temporal, and Fura, that provide this kind of service. But what if you didn't want to pay any single provider for this data? What if you could do this in a fully decentralized way using Web3 and using trustless ledgers? So if you were to start from scratch and design a storage system that is both decentralized and reliable, this is how we came up with Filecoin. So a couple key aspects of Filecoin. One, it's compatible with IPFS and Web3. So IPFS is the building block. It means that the two networks can share all the benefits of content addressing and CIDs. And Filecoin also integrates with Web3 networks like Near, Chainlink, Hedera, and others. Two, it's entirely verifiable, so you don't have to trust a single entity. You can check the content IDs that are recorded to the blockchain for confirmation that your data is still being stored the way that it was supposed to be. Lastly, it's very big and very decentralized, 8 exabytes. It's now out of date. We're just crossed the threshold to 10 exabytes from hundreds of storage providers across the globe. And this network is governed by consensus instead of any single corporation. All right, so Filecoin. How does it actually work under the hood? This is the workflow of storage deals that kind of powers Filecoin. The first step is that you or your app make a deal with a provider to store your data. And once that deal is agreed upon, Filecoin preps your data. It translates it into a directed acyclic graph. It uses the same processes as IPFS, so the resulting CIDs are totally compatible between the networks. Next, the storage providers generate an initial proof of replication, and that's the part of the storage deal that they publish to the chain. So once that initial proof of rep hits the chain, that means your storage deal is active, and it starts running. So over time, providers have to keep proving that they still have subsets of your data, and we call those proofs of space-time. As they continue to submit correct proofs, they're paid incrementally for keeping up the storage deal. And when you're looking to retrieve your data or get it back, you make retrieval deals that kind of use the same mechanisms to get your data back from providers. And so this is a series of steps that puts really usable and reliable kind of metadata artifacts about your storage on chain. It provides a universal reference. So if anyone wants to verify, if you want to verify that the data has been around for a certain period of time, or that the data hasn't been tampered with or decayed, the CIDs on chain are kind of a really great resource to be able to do that. Now, all this back and forth is just for your information, because when you come to use Filecoin, there are a number of tools that simplify this for you into a single API call. So it becomes as easy to use as AWS, for example. And I'll talk through some of those tools in a moment. But essentially, this is the relationship between IPFS and Filecoin. So IPFS provides a lot of resources for fast and flexible retrieval. There are gateways that bridge from your standard HTTP network to Web3. There are different options for installing local nodes, for integration into browsers. And then Filecoin is kind of that persistence and verifiability layer. Earlier, I said I would talk through some of the services and tools and libraries that make it easy to build on top of Filecoin and IPFS. And let's jump into that now. First, I want to go back to this stack diagram, right, where you can have Web3 built in to your applications at all different layers. So you can load your front end from IPFS. You can log in with DWeb wallets. You can use storage helpers to put content on IPFS or Filecoin. And we're going to talk about some of these tools in just a moment. So Fleek is probably one of the very easiest tools to get started using IPFS. It's basically a way to host your site or application on IPFS. All you do is connect your GitHub repository, add some build settings, and it automatically deploys for you. You essentially don't need to understand how IPFS works under the hood to get this set up, but they have some great, logging and debugging tools to show you what's going on. This is a great way to get your websites and web applications on the open web. It's compatible with almost any modern web framework. And it's basically dead simple to use. So this is a great way to get started if you're just looking to host your IPFS, host your web content on IPFS. There are also a bunch of different storage helper tools. Like I said, really recommend choosing a storage helper. It simplifies deal making. It stores to both types of networks with a single call. One option, if you're building desktop apps specifically, is to use Fleek's Space Daemon SDK. It combines IPFS and some Filecoin tools into one background service. It runs on your users' desktops, and it can be bundled with the desktop app. Another really great service is Estuary. It's designed for both for general IPFS and Filecoin storage. There's really seamless deal making and verification available. You can see the web interface on the left here, but the majority of the usage actually happens through the HTTP API. And in the middle screenshot, you can see some of the deal tracking tools that let you see exactly what's going on with your data. It's uploaded immediately to a hosted Estuary node, so it's available on the IPFS network. And then that node goes and makes storage deals with 6 providers around the web to ensure that your data is also stored more permanently on Filecoin. This is a great tool, especially if you're doing any sort of high performance and large scale data storage. Another tool to know about is NFT.storage. So this is basically an API library and service designed specifically for storing NFT data. When you upload your data, you get back really nicely formatted metadata that's designed specifically for storing NFTs. There's a JavaScript client library available, an HTTP API, And you can also configure this as your service, as your remote service in IPFS. The docs have some great examples and great illustrations of what's going on behind the scenes. So this is another great way to get started. The last tool I'll share is Powergate. Powergate, I think the name is very appropriate. I think it's also a power user tool. This has some really great integrations and bridges to Near, Polygon, and some other Web3 services. If you want a lot of configurability and options, this is a great tool to consider. So essentially, it's a Docker container wrapped around an IPFS and Filecoin node with a bunch of configuration options that are set by default, but you can also change. It essentially use a few different commands to stage and store and retrieve your data. It works. There's a JS and a Go client, and it uses a gRPC API, so you can kind of bundle it into your application. So those are some of the tools, the storage helpers that are available. We're really excited to see a lot of developers using these. It kind of opens up the doors tremendously for building on top of Filecoin and IPFS and storing your data in the new world. There are a few resources that I wanted to share. The first is this verifying storage on Filecoin tutorial. This walks through a bunch of the concepts that are at the root of everything that's going on with the Filecoin protocol and how it works. So this is a really great tutorial. It's also part of Proto School, which is a fantastic resource for additional interactive lessons and courses on some of these key concepts for Web3. So this one is great. This is a content addressing course, and I think this is a great one for anyone interested in content addressing and CIDs and using content addressing on the decentralized web. Another tool that I want to reference is the documentation for Filecoin. There's a reference with links to everything, but also some getting started tutorials and explainers. So that's a great resource. And then if you want to understand what the heck is going on, how does this all work? This is a great paper to check out, Engineering Filecoin's Economy. And this talks through the different aspects and leverage points and incentives that are designed into the Filecoin network to make this all happen and provide free storage for a lot of humanity's most valuable data, at the same time compensating storage providers for contributing their resources to the web. Lastly, if you need anything at all, we've got a great team that's available to answer questions or just chat, talk through your ideas in the Filecoin Slack. Filecoin.io/Slack links to the token, to an invite to join that Slack, and the Phil Builders channel is the place to find lots of these people. And you'll be hearing more from this at the end of the hackathon, I believe, but we have a fantastic microgrants as well as open grants program to support your independent projects that use IPFS or Filecoin or any of the kind of layer 2 tools that I've talked about. So you can find all the info at grants.filecoin.io, or you can shoot us an email at grants@filecoin.org to learn more about these programs. Let me go in the chat. I think I see a couple questions. Cool. First is a shout out to Ian, who runs an IPFS node. Awesome. And thanks, Andy, for inviting anyone to post questions to the chat. I'm going to stop screen sharing now. If there's any questions or things that people want to know, let me run through these. Okay. Any docs for accessing data and integration with Web3 interface? So Web3.storage is probably the best place to get started. Actually, let me make sure I understand your question, Srikar. Are you talking specifically about the Web3.storage API, or are you interested in more generally understanding data and integrations more generally? Okay. Let's see. I think the Filecoin docs is a great resource, and then also going into the Phil Builders channel. If you kind of explain what you're looking to do or what you're looking to build, you can find people there who can give some guidance or comment on your designs. Can we fetch data from Filecoin just like a normal backend? So currently, fetching data from Filecoin has some delays, and that's why we're really recommending that you use some of these storage services, because they provide an IPFS layer in addition to Filecoin. So IPFS provides that really fast, flexible retrieval, and then Filecoin is essentially like your cool or cold storage. If you use Web3.storage or Estuary or NFT.storage, all of these fetch data just like a normal backend. Let me try to show you an example from here. So this is the retrieve function, and it's to use it as a single liner to get your data back. Is there moderation or censorship of content is what Thomas wants to know. Okay, so I want to make a distinction between protocols and services. So just like HTTP itself doesn't censor content, Filecoin and IPFS protocols do not censor content. But any of the storage services that we enable all have a code of conduct or terms of service that represents what these providers are willing to support. So you can imagine, for example, nodes in Europe want to support GDPR. They can actually, the nodes actually can publish their content policies. And when you make a deal, you can check with each provider, what is their content policy? What do they support? What do they not support? If you use any of these services like Web3 storage or Estuary, they basically deal with miners that support the policies that they want to enforce. If you make storage deals directly with providers, then you can follow any sort of content policy that they want to promote. FilRep, which stands for Filecoin Reputation, is one of the underlying tools that you can use to sort of examine miners. Over time, it'll include their content policies, but this describes like how they're ranked and published, and it even includes, I don't think it's live yet, but it's actually going to include a note for providers that use renewable energy, which is super cool. Any links to learn more about Filecoin hackathons, grants, opportunities? Yeah, absolutely. Let's see. Grants.filecoin.io is probably the best starting point. All of the processes happen inside this Dev Grants repository. So you can read about next step microgrants and the details there. You can see some of the accepted proposals and just check out, what are some of the more outstanding proposals that have gotten funded. You can check out the open grants workflow as well. And then this section, RFPs, includes some of the areas that we're particularly interested in funding. Right now, we have a lot of joint grants for Web3 integrations. There's a couple, storage provider tools outlined here. There's more of these coming. So these are kind of specific areas of interest that that we have a technical sponsor for and a funder for, but you can also apply through the Open Grants program as well. Jose, if you have any questions about that and you can't find the info that you're looking for, just send us an email to this address and we'll direct you to the right path. Mike wants to know, what's the cost to using Filecoin? Does every API call require a transaction? The are you talking about the financial cost or the bandwidth cost? Maybe I'll try to cover both of those. So there's a really okay, great, really cool program called Filecoin Plus that is at the heart of some of these programs. So it basically incentivizes storage providers to prioritize useful data, and that's what we call, data from anybody who has applied for this thing that we call data cap. Both Estuary and actually primarily Estuary, but NFT storage as well, do some very lightweight screening of users and then provide storage for free, because essentially for providers, it's more valuable for them to store real data and then earn block rewards based on that than to store garbage data. So this means that services like Estuary and Web3 storage and NFT storage can offer free data for consumer usage. Shubham wants to know, amazing, can we structure our data like we do in different databases? You can structure your data however you want. When it gets imported into these networks, CIDs are generated, but when you retrieve them, they get returned to you in whatever format that you put them back in. Basically, it serializes it into a car file and then deserializes it when you read it back out. Any links for open source applications using any of these data storages you mentioned? If you want some demo applications, the documentation has some examples, and so that would be a good place to look. And then there's an image gallery example for Web3.storage that you can walk through, and then I think there's a full GitHub repo that you can fork and play around with. Does storing and calling cost you token and gas fee too? It does not. The costs is free to end users. It does when you make the deals. Yes, there is a small amount of gas fee associated with writing anything to the chain. Great. Well, I think that's the end of the questions that I see. Anything else, feel free to find us on filecoin.io/Slack. My handle there's Mosh. I've left some email addresses and contact info in the chat. And thanks everyone for coming and talking decentralized storage.
Thanks, Michelle. We'll end the stream here. Remind everyone they can always go into Discord also and find the full team there. More workshops this week. That was a great presentation, Michelle. Super appreciated. Goodbye, everyone.